Welcome to Everyday Asphalt. My name's Jim Warren, and we're glad to have you here today. The purpose of this program is to go a little bit deeper in the areas of materials, design, construction, and maintenance. All these programs are recorded and will be replayed on our YouTube channel. It's if you go to YouTube, Apex Techs or Apex Texas, and check us out in the playlist. We're also on Spotify, Apple Podcasts, and some of the other audio versions as well, and those drop the day of the show, which is always on the third Thursday of the month at 3 p.m. Central. So, let's see. Please, while you're there, while you're watching these things, please like, subscribe, and share. Let other people know. We're trying to grow our brand, if you will, with this program. But we're glad to have you here. So today, this is going to be fun. I've got Matt White, who is the
North Texas Regional Director.
North Texas Regional Director for TexUp, and you've been on board for how many months now?
About three, going on three.
3 months.
Yep.
So you're still a probie.
That's it. Absolutely. That's fair. That's a fair statement. There's no question.
Still wearing the ankle monitor.
Yep.
Matt White is here. Matt's got a very extensive background in the equipment side, and that's something we haven't really spent a lot of time on here today, on this program. And so we're going to talk about it kind of from a design and from a construction standpoint. Get into some detail on mills and pavers and rollers a little bit. No brand specific stuff here, but we want to spend some time on that today. So Matt, welcome. Welcome to the party here. Glad to have you here.
Thanks for having me.
And for those that don't know you, can you give us a little bit of background, kind of where you born, where you grew up, how you got into this crazy business?
Sure. So born in Jackson, Mississippi. Lived there most of my life. Spent a little bit of time in Baton Rouge. My dad got transferred when I was a youngster. And spent about 6 years in Baton Rouge, but family's all
you're
originally.
a Southern boy.
That's it.
All right.
That's it. So spent my high school time in Madison, Mississippi, and then. Kind of a pretty interesting story as to how I kind of got into this industry.
All right.
Right out of high school, actually, kind of been a gearhead all my life. Really enjoyed cars. Really enjoyed tinkering with Mustangs specifically. Had a couple Mustangs coming up, and
all right.
So
what was the oldest Mustang you had?
Well, the oldest that I had was a 2000, right? So I'm probably dating myself. I know that's not super old, but I had a buddy that had a 66.
All right.
And that was a lot of fun.
Nice.
He also had a 1990 fastback. So we were always tinkering and doing stuff like that. So right out of high school, ended up going the technical trade school route. Didn't go to college, didn't go to university, but
great opportunity.
Yeah. So actually, I went to Universal Technical Institute in Houston. So for basic automotive.
Okay.
Yep.
All right.
So working on cars, bumper to bumper. No body work, no sheet metal, nothing like that. But
dang it, I got it done. Yeah.
I would say my favorite classes were the power and performance classes that they had.
Do any diesel work?
Very little. We touched on the diesel side, but more than anything, it was learning automotive system components, if you will. And again, that power and performance side, we got to build 350 short blocks and put them in T-buckets and run them on a dyno, and so that was really cool.
Neat.
That was fun. So
awesome.
But yeah, right after high school, went to technical trade school, and then ended up going to work for the Mercedes dealer there in Jackson, Mississippi. Went back home. And worked at the Mercedes dealer in Jackson, and so. My wife and I met when we were both in Houston going to school, met through some friends, and kept in touch long distance. And I said, I love what I do, but man, I got to try somewhere different. I'm going to throw a dart at a map and kind of see where I land, and ended up landing in Nashville.
Oh, wow.
So went to work.
Okay.
Yeah.
All right. Now it's starting to come together.
Now it's coming together, yeah.
All right. Okay.
So went to work at the Mercedes dealer in Nashville, and my wife and I became friends with a couple from Germany. And got to talking to him, and what's this vehicle you drive with this funny German name on the side, and what is it? And kind of found out about the some of the manufacturer side of things and the construction world. So So long story short, applied for a job as a field service guy, and was hired on, and had some real interesting conversations, applying, coming from the automotive side, going to the heavy industrial side. And, so basically said, hey, if you guys are willing to give me a shot, I want to learn more about hydraulics and I want to learn more about welding and some basic
Gotcha.
fabrication. And,
Okay.
the pushback was, well, yeah, but I see, you've worked on automotive. It's very small stuff. This is very big stuff. I said, yeah, but if you'll teach
It's
me,
the same stuff.
I'm willing to learn.
It's just bigger.
Yeah,
Bigger
and
cylinders, bigger motors. and
That's
that
it.
sort
So
of stuff.
they took a chance on me and
Wow, that's
went to
cool.
work for German manufacturer based out of Nashville and
working.
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 Yep, that was working
It's
America.
okay. You can
yeah.
say it.
No, all right.
It's okay. They're a member.
So yeah, that was 2010.
Okay.
And so it was pretty funny. Didn't really know exactly what I was getting myself into, but had been with working for about 2 weeks, and my boss said, "You got your passport, right?" And I said, "Yeah." And he goes, "You want to go to Canada for a little while and learn some stuff?" I said, "Sure." He goes, "Well, fly to Edmonton, Alberta, Canada. You'll meet a German guy up there. He'll teach you everything you need to know." And went up there for about 2.5 weeks,
Wow.
working on a cold recycler actually.
Okay.
And that was again my first exposure.
Really
to,
like working on it.
Yes,
Okay.
working on it.
Okay.
So we
Wow.
were assembling, and then we were troubleshooting, and so that was really the
Boy,
beginning.
talk about hands-on, man.
Very
That's cool.
Very. So
Yeah.
it was super
Like,
cool.
okay, that's what it looks like on the inside. This is
Yeah.
where this goes. This
Exactly.
is how this functions is relative to that.
Exactly.
Ah, that's neat.
Exactly.
That's cool.
So
that's cool.
that was, like I say, that was May of 2010.
Okay.
And so since
They're
then,
still kind of in the recession.
yeah, coming out of it.
Coming out of it,
coming out of
okay.
it a little
All right.
bit. But yeah, things I would say weren't blowing and going. You know,
Okay.
they were still kind of ramping up, if you will. So, but yeah, it was
So then you came back.
Yep. So when we were pregnant with our first, wife's originally from Texas, and so had the opportunity to move back to Texas. Was traveling, covering 50 states in Canada. So
Whoa.
as long as I was close to an airport, didn't really matter. So
That bag will travel.
yes,
Okay.
for sure.
So
So
you spent a lot of time in the field.
a lot of time. Yeah.
Okay.
Yeah.
Okay.
Yep. Probably, I think 4 or 5 provinces and Europe a little bit for some training and I don't know, 45, 46 states here and, across the North American.
You get your
continent.
million miles?
No, not yet.
Not yet?
Not yet. Not quite. But yeah, there were some times I was scratching my head going, what did I get myself into? But it was a lot of
That
fun.
can be hard.
For
Being
sure.
gone a lot, if you got a young family, that can be. If you're
For sure.
traveling a lot, that
yeah.
can be hard.
Yeah, it's easier as a young man to do that type of stuff, and I'm
Yeah.
grateful for the opportunity to have
Yeah.
done it. So,
Okay.
but yeah, that was 2010, and so from 2010 to now 2026, really been in the industry, and again had the fortunate opportunity to work for a couple different manufacturers, a couple different dealers.
So how did you get to Texas?
So
How back?
So got back to
Back to
Texas.
Texas.
Back to Texas with my wife when we were pregnant with our first kiddo.
And then you went to work for who?
Then I went to work for shortly after Nueces Power Equipment.
Okay.
Yep.
Okay.
So went to work for the dealer,
Okay.
kind of covering some of that East Texas market and
Okay.
Houston and.
So your circle got a little bit smaller.
Correct. Yep.
Okay.
And it was great. I mean, again, it just speaks to the industry, right? I went to my boss at work, and after we'd moved back to Texas, and said, "Man, I love what I do, but the travel and what really got to me was our second son was born. He was 2 weeks old, and I went to Alaska for almost 3 weeks.
Oh, ouch.
And I came home, and I said, I maybe should think this through a
Yeah.
little bit. So,
Okay.
but again, great people, great industry. Went to my boss at the time and said, "Man, I love what I do, but the travel." And he said, "No worries. If we can help,
Yeah.
keep you in the industry,
Yeah.
anything like that, you got some great dealers, you got some great support around you,
Okay.
great contractors.
Okay.
Just let me know what I can do to help."
Awesome.
So
Isn't that cool?
again, speaks
that
to the industry.
Speaks volumes.
Yeah, so-
great. That's the thing. Again, I've told y'all before, but I think that's the thing I like about this. I love asphalt. I think it's the best thing out there. But I love the people in this industry.
Yeah.
They're just the best people, and it's just we're a melting pot of all kinds of different people from different areas, and I'm gonna work to try to do the right thing, and
Yeah.
that's the cool part. That's the
Absolutely,
cool part.
absolutely.
So, and then you moved to
So
from Nueces.
yeah, from Nueces, then I actually went to work for Bomag Americas.
Okay.
And looked after the milling machines and the stabilizers for North America.
Okay.
So that was
So you got back on the road then.
got back on the road. Yep, back on the road.
Okay.
Back on the road. I mean, it's it's one of those I've always said I love the travel, but I hate being away from
Yeah.
the family.
Yeah.
Right.
Yep.
It's great.
Yep. Yep.
But yeah, it's some different demands. And the cool thing about that role is we were making a pretty big push into Texas, right, in
Yeah.
the southern markets. So
Okay.
again, still covering North America, but had some focus in
Okay.
the southern region almost, if you will.
And then from Bomag,
Then to Kirby Smith.
Kirby Smith.
Yep.
Okay.
Yep.
And that's
So-
where Tex Apple stole you from.
That's where Texas. Yeah, that's it. That's it. So, but great opportunities from working on the equipment in the field to application.
Yeah,
really
absolutely.
got really entrenched in the recycling side of it, the road
Mm-hmm.
recycling side, the base stabilizing side of it, and so again from working on it to application to training, and then at the dealer level, right, seeing a lot of the different areas and being fortunate enough to have worked in a lot of the different areas from service and sales and rentals.
Awesome.
Fantastic opportunities and man, great people along
Yeah,
the way.
first time I met you, I went, yeah, he's gonna be all right. But no, good deal. So what we wanted to do today was bring you in, and we wanted to kind of talk about a couple issues that have come up in some of the education stuff that we've been working on that we've run into. I know some of the stuff we were talking about earlier this morning was this is what we're going to talk about today. Yeah, it's the same stuff, but a lot of people don't understand it from the equipment side.
Sure.
I mean, they're an engineer or they're from another area, and they don't really understand what these things can do. And if you can't see it, there it is, or there it is, and up from that position, there it is.
Yep.
And that one too. Gotta be agnostic here. There's others as well. And if you are not shown here on the table and you'd like to be, send me one of your toys and we'll get it
Always
up there.
open for new models.
Always open for new stuff. I like toys. So that's what we kind of wanted to do today, is spend some time on that. And one of the key principles of this Apex program is to kind of break down the silos between people that are doing design, and that includes roadway and pavement design. And I'm glad you mentioned the base, because that's a huge part of our design,
Sure.
right? And if we don't do that right, it doesn't matter,
Absolutely.
right? And then also talk some on the construction side of actually using it and specifying it and what we should be looking for when we're actually out on the road. So let me back up a little bit. Again, you've worked on this. We don't have a reclaimer, but we don't have an MTV. But you guys, the company you work for didn't sell the kind of like the standard MTV that's out
Right.
there now. But I wanted to kind of back up a little bit, of just making sure people understand. Let's just talk about size of equipment.
Mhm.
I kind of always looked at kind of like three general sizes. What for like pavers and stuff? What's
Sure.
your thoughts?
Yeah, I think you get into some of the smaller driveway size
Yeah.
pavers, right? That kind of class of paver. Then you get into kind of the 8-foot size, right? Maybe more of a commercial crossover between commercial and then 8-foot lighter duty, secondary, tertiary type road pavers. And then you get into the highway class, really 10-foot pavers. So I agree with
And
that.
10-foot means what?
10-foot means the basic width of that screed
Okay.
is 10 feet.
So it's a minimum of 10 foot.
Correct. Yep.
But
So
it's not exactly 10 foot, right? We got a little
there's
bit of-
some variance. Yeah.
Yeah, but
there's-
I mean, we can't put a 10-foot screed in a 10-foot hole.
Correct. Yes. Yeah.
And
You're going to have overhang from
Yeah.
the side plates for the end gates, right? And then
Yeah.
obviously you've got tractor in front that's depending on model can be a little narrower, but can be kind of the same width,
About same
right?
width.
So
Okay.
yeah, you've got to. That's a great point when you start looking at these things. Just because I have an 8-foot trench, if you will, or a 10-foot trench, I can't set that 10-foot machine in it, or if I do, I don't have any wiggle room. I don't have any tolerance.
What would be a reasonable, say like I got a 10-foot machine, I got and I want to do I'm not doing 12. I want to do as close to 10. How wide do I need to? Do I need to be 11?
I would, yeah. I mean, I would give yourself at least 6 inches
6
on either
inches
side.
on either
Yeah,
side.
yeah,
Because it's probably at least 3 or 4, right?
yeah, for sure.
Between the end gate and anything else
Correct.
that's hanging on the outside. So that's just, again, something to recognize when we're doing some of this kind of stuff. And just since we're talking about widths, you've got a mill here. And again, they're configured a little bit differently than a paver is.
Right.
So what what kind of standard widths do we see in the mill world?
So typically for half lane machines, which is kind of the standard, if you will, on average you're 7'2", 7'3", right? So
Okay.
like that particular machine at a 622, that's going to be a 2.2 meter or 7'3" drum.
Okay.
Those are pretty standard. You'll still
Okay.
see some 6'7" machines,
Okay.
but 7'3" from a half lane perspective is pretty
It's
well
kind of
standard.
the standard now
Yeah.
that you'd see running around here, and
Correct.
pretty much anywhere in Texas.
Correct. Yeah.
Okay.
Yep. Yep.
So, can I cut narrower than 7'3"?
In certain applications and certain configurations, you can put a smaller drum in that same size housing.
Okay.
So there are setups where you could put, let's say you had a 6-foot housing, you could put a 5-foot drum, or you could put a 4-foot drum, or you have a 4-foot machine, you could put a 3-foot or a 2-foot drum. Now the housing may stay the same.
So
right?
the housing would be on top of the surface, but then the
Correct.
drum would slide down into the cut.
Right. The drum
Okay.
would slide down, and then the way that the rear door is designed is just to scrape that 3-foot section or that 4-foot section versus the wider original configuration.
Gotcha.
Yep.
Okay. All right.
So, but to your
So why
point,
do go ahead, please.
no, I mean that's a great point on understanding kind of what's standard out there, right? And manufacturers, especially on milling machines, you can get anything from say a 3-inch trenching wheel on a very small milling machine all the way up to 14 feet 4 inches, right? So there's a wide gamut of options out there, but it's not standard, right? So most of your your milling and paving contractors, your rental houses, they're not going to have something of every make, model, and size in between,
Yeah,
right? So
okay.
understanding 7'3" is maybe your most standard
Okay.
when it comes to designing, when it
All
comes
right.
to thinking about those things.
Okay.
That's very important.
Okay. Okay. That's good to know. And then why do we have a half lane machine? Why don't we just do the full lane?
Transport's one big issue, one
Okay.
big item, right? Typically, if you're trying to stay under 10 feet wide, or depending on the state or the the low boy may be 8 feet wide, right? But we can get it oversized for a little bit wider. So typically, hauling, transport, and then again, when you get into those bigger size machines, let's say you had a full lane at 12'6", and you got to have a lot of trucks lined up ready to go for that. And
Okay.
so a contractor to have that size of a machine, that investment, may not give you the flexibility that a half lane machine would give you to still utilize it. And the great thing is now modern day milling machines with electronics and the ability to match your previous cut, most of the machines can do it no problem, right?
Okay.
So you're not
You
looking
don't have that little
you don't have
ridge.
that lip or that ridge.
Okay.
Exactly right. So,
Gotcha. Okay. So standard paver, 10-foot, but you got to allow for the overlap.
Right.
So maybe 11 foot ish
ish,
range.
yeah, yep.
In that range for if you're having to do some inset paving. And then mills are 7'3", 7.5 feet,
Yep.
something
Yep.
in that range. And then get what we typically see with if we're milling 12 foot, obviously they're going to make 2 passes. There's some overlap in
Right,
there as
right.
well in the process. What about rollers?
Again,
there's-
right, man, it,
What do
you
we
know,
see for typical highway stuff?
typical highway, you're going to be 78-inch or 84-inch size
Okay.
rollers, right?
Okay.
66 are very, very popular as well, but 78
They
inch.
they were more at one time.
Yeah.
If you go back far enough.
You see a lot more 78-inch.
Because they can cover a mat
Correct.
up and back.
Correct. Yep.
Okay.
Yep. When you're
Okay.
talking a full,
So
full
same
lane.
same concept.
Same concept.
Okay.
Exactly.
But then they go all the way down. And
Yeah.
is there anything bigger than an 84?
Not that
I think
I've
that's
seen.
something I've
No,
ever
not
seen.
that I've seen.
Okay.
No.
That's a big chunk of iron.
It is. It is.
Yeah.
And again, rollers, right? Same thing. You've got some manufacturers that have rollers down in the 30-inch. As far as ride on, you get smaller. Into some of the trench rollers and
Yeah.
things like that. But when it comes to asphalt rollers, your most common, right, is going to be probably or most standard from say 36, 39 inches all the way up to 84 inches. So again, figuring out that right range, the right size for what you're doing is key, right? Because you want to make sure you've got enough overlap, but you also want to make sure that the roller can keep up with the paving train, for example.
Right. If you're trying to pave 12 foot of SMA, you don't have to with a 39-inch.
Right, exactly.
Probably not a good idea.
Not a good choice. No, not a good choice.
Not a good choice. Do you see a lot of? We saw this in the old job, and it happened when they changed the density spec and changed the spec. They went from running rollers like this to doing the offset rollers.
Yeah.
You seeing more of that now?
As
Or it
far as
depends.
the individual single machine with two drums that offset, or
No,
are you
no,
talking
just actually two machines.
two machines?
Kind
Yeah.
of running, instead of running like this.
Yes.
They're actually running together.
Yes. See that very common.
I've
I
seen
mean,
it,
very,
the Thunderbird technique, or
Yeah.
the Blue Angels.
yeah,
The
it's
Blue Angels technique.
very usual, especially again when you get into highway paving where they're trying to get on the mat early, they're trying to get the brake down at temperature, right?
Yeah.
And they're trying to keep up with the paving train that's typically moving along at a pretty good clip. It's
Okay.
very standard.
So let's back up on mills just for a second. Planer, Texas calls them planers. I'm not sure where, but it's in the spec. It's planing. But milling, planing, we're using the word interchangeably here
Sure.
today. Let's talk about what can it do? What can it do? I'm gonna probably go ahead.
Yeah. So, the milling machine, I think you're kind of, when most folks think of a milling machine, kind of your standard is, say, a 2-inch mill and fill, right? It's 2 inches, you're removing that top layer. But, most machines nowadays, they're getting down to full depth, right? They can get down to 12, 13, even 14 inches in depth
Wow.
to pull out, 100, obviously the wearing course, the intermediate layer, the base course.
Hogging all out.
Hogging it all out. Now,
Okay.
again, this is where it comes into, just because I can, does it mean that I should, right?
What's the drawback? So
Sure, yeah. So I mean, when you start looking at operating a machine like that, you can increase, tooth consumption, fuel burn, right? And then again, depending on how much horsepower you have in that milling machine, how many trucks you have, again, it's just what's the balance. I've seen it a lot of times where the request is, oh man, we got to have an 800 horsepower mill. We got all this milling work to do, and then you show up on the site.
need more power.
Yeah, and we've got 6
Tim
trucks.
the tool man, right?
Yeah, and so we drop it in the cut, and we go, and we load those 6 trucks, and we run, and now we're sitting for 45 minutes.
Okay.
So a lot of times, again, there's a ton of capabilities out there. Just because we can doesn't mean that we should, right? Maybe a 600 horsepower mill is better suited. A little slower, right? A little less fuel burn, a little less tooth burn, but again, we can run nice and steady, say, to match what our trucks are, if depending on trucks. And logistics is a huge part of that as well.
Kind of like the old tortoise and the hare deal.
There you go.
Right?
That's it.
But
That's
run
it.
like bat out of hell for a little bit and then sit.
That's right.
Okay.
That's right. And sometimes on these, again, they've got the capability to do it, but you'll find things run smoother, things run more efficiently if you can
Kind of in that middle range.
in that
and
middle
it's
range.
supposed to like max. into that.
Exactly. And if you have the ability to pull out, the layers in multiple passes, right? But again, logistics don't always allow for that. Job site constraints don't always allow for that. So there's just a lot of different things. But as far as machine capabilities nowadays, it's really amazing the technology that's in them, how advanced they have come, how far they've come, how advanced they are. But again, there's still a lot of the basics, the fundamentals that you go back to.
So let me, before you go on, I just
Yeah.
want to, so if we got a layer,
Mm-hmm.
maybe there's a layer of, maybe we're trying to mill out several layers. And we've talked about this here because of the aggregate quality issues in certain areas about, our SAC A materials, our best material at the surface. We could, if we wanted to, we could selectively mine that material out.
Absolutely. Yeah.
And then come back and mill the next layer out. But if we mix it all together,
Yeah.
we will lose the ability to maybe cull that material out separately.
Correct.
Maybe reuse it, because there's a lot of work being done on that right now. So that's an option, but I think that would probably, I guess it would probably be up to the contractor to determine, well, do I want to do 2 milling planing operations versus 1 and just hog it all out?
Yeah.
But if I can recover that material, and if I can reuse that material at a higher SAC classification than a SAC B,
Yep.
that may offset the cost difference of having two milling operations.
Correct. Yeah.
right?
And I've seen that in a lot of job sites, a lot of applications where they say, hey, we're just going to chase this down till we get through the asphalt, and then we're going to come through and we're going to pull the base out, right? So that it's not uncommon to see that.
Okay.
But again, it's not always feasible because of job site constraints and logistics, but it is something that, again, it's it can be much more efficient that way when you look at the total cost of production, the total cost per hour for that machine.
Gotcha. And we have seen that recently on a job out in Pecos, where they did an intersection and they milled 8 inches down, and they put it back in one lift, with some of these newer technology mixes that we've got, and with the higher type binders and stuff, and it works.
Yep.
It works.
Yep.
It's there's drawbacks to every technique, but if you're from a speed of construction standpoint, this stuff really, I don't think in many cases we use it to the extent that we probably could use it.
Yeah.
Because there's just, we're doing kind of this normal stuff. Not that we're always going to do this exotic of, taking out 2 foot of material or something like that.
Right.
But I think it's important. I think if you're a designer, you kind of ask the question, right? And you don't be afraid to ask, well, could we do this?
Yes.
As opposed to, well, all we do is mill and fill. All we do is 2-inch mill and fill. Well, this is pretty easy for everybody, but it may not be fixing the problem. And we've seen that on a number of jobs where, there was a distress in the asphalt because of something. They milled it out, they put exactly the same thing back in, and then they had a distress in the asphalt, and they milled it out, they put exactly the same thing back in, and they go, well, the asphalt's not working.
Right.
Well, I'm going to go time out.
It's kind of the definition of insanity.
Yeah, absolutely. I know that one well. But having that option said, well, maybe the problem isn't here, or maybe the problem is at that 2-inch interface.
Yep.
We've got a lot of stress built up right in that area. Maybe we need to go down deeper, and maybe we could take it all
Sure.
out, or go deeper and do that. So there's they just finished an intersection, I think it was at 79 and Hearn.
Yep.
That with that, and they took out 4 inches of asphalt. It got down to pretty much, there was some concrete down below, and they're having some real heavy intersection, heavy duty intersection or roadway section for about a mile or so. Just went through it this past week. They did a real nice job of it, but they milled 4 and they put 2 2-inch lifts back.
Yeah.
And I think it's going to work really well.
Yeah.
So I think there's things, I think, from a designer perspective that I think we need to say, hey, we really would like to do this, but can we? And I think the question is just ask.
Yeah.
You can ask us, or you can ask TexAPA, you can ask your local contractors, and it may just say, well, we like to do 2 inches. Well, what if we, they would probably rather do 4 inches than see it go to the other paving material.
Right.
And so let's maybe think about that as some options as well.
I think you bring up a fantastic point, and I think to summarize all of that, and not to sound cliche, but it's communication.
Oh,
And again, sounds
Absolutely.
so simple, sounds
Yep.
cliche,
Yep.
but truly communication in pre-con meetings, right? Communication between the contractor, the road owner, the foreman. I mean, everybody's got to be in lockstep, and everybody's got to be able to communicate. And there is, again, speaking to the industry, this industry is fantastic when it comes to people, and there's so much knowledge that's out there.
but we don't share it, do we?
No.
Not as much as we should.
Right. It's sometimes the best kept secret.
Yeah.
Unfortunately.
Yeah.
So
I'm not
it's
gonna tell you. Yeah, not-
right. Exactly. But there's so many contractors that have so much wisdom. There's so many operators that have so much wisdom. There's so many engineers that have so much wisdom. But they're all in different areas, right? They may focus in those areas. But man, if we put our heads together and we figure this out, and again, we talk about it, we communicate on it and say, hey, what about this? What if we try this? Or, hey, we've noticed some scabbing. Can we go a little deeper? Or, hey, do you want us to come up a little bit versus just milling over it,
Or
leaving
just
a
leaving
scab?
it.
Yes.
And then have it delaminate.
Exactly.
And then the whole pavement slips.
Exactly.
That's what I've seen.
Yes, exactly.
And yeah, absolutely. I think that's a big deal. And I would even go back further. I think we need to go back and again, I'm not picking on the designers today, but I'm consciously aware of this idea that we're trying to break these silos down.
Yes.
And designers generally talk to designers, and construction people and materials people talk about VMA and SAC-A and that kind of stuff. And no offense, I've been on most sides of that. And maintenance people are, they're how do we maintain this thing, right? But if we don't take that opportunity to crosstalk,
Yes.
you know, and when we're designing a project, the design, we don't start talking about it pre-pay. We start talking about it maybe a year or two earlier when they're even talking about project scoping.
Sure.
And the project scoping phase is like, hey, you know, we got a road out here we got to do something with. We're not exactly sure what, so we're going to go do some forensics or some investigation, go do some FWD and some GPR and maybe burn a couple holes in the road, see what's underneath that. And then we realize, well, maybe the problem is deeper than we want to pay for. Well, if we just cover it up, guess what? It's going to come right back.
Right.
And so that is a problem, and that may be the decision. But if you're going to make the decision, don't blame the asphalt for not working right.
Sure.
You know, if we're not fixing the problem, you know, and so that to me is the big challenge with this whole thing. But again, that's why we're having the conversation today to get this out, so we can say, you know, there are solutions out there. Go talk to the operators, go talk to the contractors, bring them into a meeting, say, hey, we're scoping out this job site or this job. It's from here to here on this road. We've got here's our issues with this thing. We can't shut it down. We can't do this, you know, whatever. What could we do with this stuff? Right? To make it better and to fix it right.
Yep.
You know, instead of just fixing it, let's fix it right. And then we can go on and go from there. Okay.
Well, and even to that point, if you know you've got failures or you know you're scoping the project and we've got to do base repairs or subgrade, we've got subgrade issues, don't scope a 6-foot patch, right? A 6-foot patch is going to be pretty tough, right? Because again, we
Can't
could
drop
go
it. Then I got to do it by hand.
we got to figure something out. We got to
Yeah.
take a 4-foot mill, for example, and maybe not everybody has a 4-foot mill, or we've got to take some, you know, more handwork that's involved. So again, to your point, there's so many people that have the knowledge and the experience, and just, man, get outside of your little box. And I'm guilty of it too, right? But
absolutely.
have that
Yeah.
conversation, ask those questions, call your dealer, call your contractor, call your manufacturers even, you know?
So if I'm doing a full width patch, if I have a 7.5 foot width, I can bring a mill in, cut it, move forward, pick up, move that material out. I can be patching within an hour.
Yes.
You know, as opposed to making 2 or 3 hours trying to get the hole empty.
Absolutely, yeah.
You know, and then spend all that time. So production goes up. Unit cost is going to go down relatively, and quality is going to go up because now we're dealing with uniform this, that, and I don't have trucks sitting around or whatever. And I can
Exactly.
just kind of get in and get out and move
Yes.
on. So again, some things just to think about kind of as we're kind of going through this. So all right. So anything else? Okay, I want to talk about, again, we go back to planing and milling for a second, because this comes up a lot. I can mill for depth,
Sure.
right? What's the difference between like a mill and fill and like what I would call profile mill? And that's where we're kind of trying to take this out.
Yeah.
What's the difference there?
So mill and fill, let's say we're milling down 2 inches, we're cutting out 2 inches, we're cutting down 2 inches, we're following what's there existing, and we're paving back 2 inches following what's there.
So we're not going to get much change in ride.
Ride, correct. Ride's going to stay theoretically
much
the same
the
because
same.
all we're doing is we're following what's there.
Okay.
Right? Now, if we're talking profile milling,
Okay.
we've got some humps and bumps and whoop-de-woos and all that, then we may look at something where we use multiple sensors, right? Like a big ski or a multiplex, it may be called.
And what's a multiplex?
So really, you're utilizing multiple sensors
Okay.
across the length of that machine. So
Like
now,
on a paver.
exactly.
Okay.
So instead of just using basically one point of reference to follow, now we're using the length of that machine, say 25 or 30 feet long, to average out those changes.
Like an old school string line.
Exactly.
Okay.
Yep.
All right.
Yep.
Okay. Electronic string line.
Exactly.
Okay.
There
All right.
have been plenty of jobs out there that you go and you mill it and you pave it, and the road owner comes back and goes, well, it's still bumpy. Well, again, what was the scope of the project? What were the expectations? How was it designed?
Key.
Right.
Real key. Real key.
So
Okay.
there's, again, the technology's out there. It's pretty commonplace, just like on a paver using a big ski, a big averaging ski. The ability's out there. It's just, again, having that communication, having that scope of project, having that scope of work.
Okay. So if I want to remove a layer and improve the ride, now what do I do?
So typically, again, a couple things that you could do. You could go back to the multiplex, for example, right? And even if we've got ride issues that may include sloping issues, then that's where maybe we cut depth on one side. We use the big averaging ski,
Okay.
and then we utilize a slope sensor to have that fall, let's say 2%.
Okay.
Right. If it's cutting back to curb reveal, if it's just trying to put slope back into the road, maybe we've even had an inversion, or we've got the road that's shifted and we need to put that slope back in. But slope is always slave to grade, right? So we've got to cut the depth, and then we've got to fall
Slope is always slave to grade.
Yes.
I like that.
Yeah.
Slope is
Yep.
always slave.
Yep.
Even on a mill.
even on a mill.
So I could cut depth on one siding and then cross slope like I do with a paver.
Absolutely.
Okay,
Yep.
so from that perspective, the technology is it's pretty. I mean, the sonic sensor stuff is pretty much. I mean, where it fits on the equipment is a
Sure.
little bit different, but it's the same.
It is. It is.
Same.
It doesn't
technology.
matter what brand it is. It's pretty standard, and it's
Okay.
been out for a
A
while.
long time.
Yep.
Yeah, a long
Yep.
time. Okay.
Yep.
All right. So we've talked about. Okay, so I can mill for depth. I can mill for ride, shall we say?
Yep.
And we're using that ski, but I still have to fix a thickness somewhere.
Right. Right.
So and then I can also change slope in the process.
Correct.
Can I do slope and thickness and ride in the same pass?
Not usually.
Not usually.
Not usually, no.
Because you only got
You-
two on a paver. You only have two inputs.
Correct. Yeah.
Right.
Yep.
You got the toe points on either side of the machine.
Right.
The drum you only pretty much got.
Yeah, you've got kind of that pivot point,
The
that
pivot point.
2D perspective, if you will. So, I mean, that's the thing again when it comes from the design side to the scope of project, being on the project, all of those things. That's where the communication comes down, because I've seen it before where you have an inspector, for example, that says, "Yeah, but I got to have 2 inches of depth and I got to have 2% slope," and you look at the
It's got to get a great ride.
correct. It's
Yeah,
it's
with
got
one
to schedule
pass.
one. Yeah, schedule one ride, and it's got to be perfect. And you look, and the road is doing this right, and we've got potholing, and it's like,
you're
okay,
going.
guys, we got to talk. What's priority here, right? And how do we fix it? Because there's ways that we can fix it, right?
Okay.
Whether we mill it down, we'd make it in 2 passes,
Okay.
or again, do we fix it with asphalt, or do we fix it with base,
Or a combination.
or a combination?
Do
Correct.
some milling, some leveling
Yes.
up, some sort of thing where we're trying to do the best we can. But I think it to me, I don't really think in 3D.
Yeah.
Okay, I can think in like 2D, and it's always been a challenge for me. It's like I just don't think in that third dimension without having to draw it out, and even that I just have I don't just I don't know. I think I have a little bit of depth perception. I think that'd be maybe where my issue is. One of many of my issues, but I think if we can at least explain what we want. And then say, okay, now how can we get there?
Right. Right.
Instead of relying on maybe what we've always done, you know. And again, we don't want to make everything this exotic thing of
Right.
flying from the ceiling with a purple unicorn, but where we have an issue, I think it's worth even having a discussion at that scoping stage, you know, where you haven't even started drawing yet. You're just saying, hey, we got a roadway, and we got this is what we've got, and this is kind of where we'd like to get to. Is have those discussions at the PIQ meetings, you know, at the partners, and you go into
Yeah,
those now. I
absolutely.
mean, you're
Yep.
doing you're a big part of that, and just saying, hey, we've got these jobs coming up, and how would you do this?
Right.
And open it up. Let's get a general group discussion. And that would be an awesome thing. You know, put a picture up and say, well, how would you fix it? How would you fix it? And I was
Right.
like, well, and then from that, you'd probably get a pretty good idea of like, I hadn't even thought about that.
That's it.
That's a heck of an idea.
That's it. And there's multitudes of ways to address these problems. There's trade-offs almost in
Absolutely.
every scenario, right?
Yep.
I mean, I love my iPhone. It's great, right? I got a big screen. I can see it. It's a little bulky in my pocket, right? That's
Yeah.
the trade-off,
Yeah,
right?
exactly.
There may be a trade-off.
Where do I put it?
Right,
Yeah,
exactly.
yeah.
So there's trade-offs to everything. And again, you know, do we fix it with asphalt? Well, now our yield's going to be off from maybe what it should have been, right? Or do I take
Or
all
I got to add that extra material
right,
in there.
right,
Right.
Or do I take it all out in one pass with a mill? Well, maybe now my tooth consumption's higher, my fuel burn's higher, but Maybe I got done with the job a little faster, right? There's trade-offs to everything. But to your point, again, communication, talking about those things, brainstorming. And man, as I've gotten older, for sure, it's okay to say, I don't know. Let's talk about it and figure it out.
That's wise. That's good wisdom. Yeah, because nobody knows it all.
No.
I mean, it's I don't care how many years or decades you've been in this business. It's because you're not ever going to know it all, and the more you realize, the more you start to know, the more you start to realize what you don't know.
Right. Coming to TexAppa, I figured out how much technical expertise and knowledge I don't have on asphalt mix designs.
Yeah. Well,
So,
pick
I know a
an area.
guy.
I know
a
a
guy.
guy. Yeah,
Right. That's what I go back
think
to.
That's the important thing.
Yeah.
You need to know the guy or gal.
Yes.
That can help you out in those areas. Let's just one more thing about this, and I'm gonna move on because
Yeah.
I know we were worried about running out of time. We're gonna run out of time. Let's talk about texture
Sure.
because I know that can be a big deal.
Yeah.
And this comes up when we're milling, and say we can open the road to traffic.
Mm-hmm.
Okay. Say we're not milling so deep as to compromise the structure.
Mm-hmm.
Say we're milling and I'm a big fan of leaving a road open to traffic, particularly before we put our surface course on.
Yep.
To allow the traffic to clean. Nothing will clean a roadway better than car tires
Right.
and truck tires. But the surface texture of a milled surface,
Mhm.
obviously depending on, let's talk about that. What determines the surface texture of a milled surface?
So the configuration of the drum or the spacing between each tooth on that drum
Okay.
from factory is what's going to set that pattern or that texture on there. And there's variations of that.
And what is a normal pattern? Should it be like this, or is it kind of that V-shaped kind of pattern?
So when you drop the machine in the cut, right, and you're sitting there or you're going slow, you're going to see a lot of tight lines, right? The faster you go, the more of those lines get spread out, turns into more of a V, right? So there's a balance there.
But what would be considered standard from a equipment side?
So 15 millimeter, 18 millimeter is going to be standard spacing, so that's going to be roughly 5/8 of an inch line spacing.
Okay, so is that a V or is that a?
It's a V.
It's a V.
It's a V.
Okay,
yeah.
all right, okay.
Yep.
Because that was one of the things I want to talk about. Because what if I wanted a linear pattern?
Yeah. So a milling drum by design is designed kind of in a V to pull that material.
Yeah,
Cut it, pull it to the center, kick it on the conveyor, and get it out into the truck, right?
Okay.
So, but industry has variations in line spacing, right? So you can go to a fine drum, or what you might hear is called a micro texture drum as well, right? So you've got different abilities, different line spacing. So you could go from, say, 15 millimeter, 5/8 of an inch, down to 8 millimeter, about 3/8 of an inch. You can go even to 2/10 of an inch, which is going to be somewhere around that 5 to 6 millimeter.
And the drawback?
And the drawback. So typically, the tighter the line spacing, number one, the more teeth the operator's got to change, which is quite the task. But more importantly, your depth. You're going to sacrifice depth. You're going to sacrifice performance as far as on the machine when you get into those tighter line spacings because it's more horsepower per tooth that's consumed.
Okay, that makes sense.
Yep.
So again, following that train of thought, then does everybody have all three of these drums sitting around?
Not typically, no.
Yeah.
No, most standard again is going to be your 15 millimeter or your 5/8 of an inch spacing.
That's a standard drum.
That's a standard drum. Fine drums where you get into that 8 millimeter or 3/8 of an inch. Those are you do see some contractors that are more dedicated milling contractors that have those, but not everybody has
But
them.
that would be I'm only doing this.
I'm only doing maybe 2 inches.
Yeah,
yeah,
max.
Yeah,
Okay.
and so typically on something like that, you're using it either to fix, say, a transition, and you're going to
Okay.
leave it open to traffic.
Okay.
Again, when you get into some of the tighter specs, you may be fixing a bridge deck, for example, where you're tenth or
Just
2
like
inch.
I'm planing.
That's exactly right.
Literally
Yes.
like with the hand plane.
Exactly right.
Just
Yep.
trying to shave off
Yep.
just a little bit of
Yep.
stuff.
You're typically not paving back on top of that because, again, when you get into that fine of texture, I think there's even, there's some discussion in industry about does it create a slip plane? Is it not
Is it too slick?
Is it too
Oh,
slick?
really?
Yeah.
Oh, okay.
Yeah.
Okay.
Yep.
Okay. So that's again just talking about kind of what our standards are for that. So I know milling is typically paid for by the square yard,
Mhm.
and that means if I'm driving a mill, I'm trying to get as many square yards as I can.
Correct.
So I'm going to be up at that higher range of 60, 80 feet a minute. It's
Right.
probably in that range.
Right.
I know if I could slow the mill down, I could take that V and make it more this away.
Right.
But I just can't tell you to slow down
Mhm.
without some sort of contractual device to say I want to mill with a certain texture in mind,
Right.
right? Because otherwise the milling contractor are going to go crazy.
Right. Right.
Hey, I bid this to get so many thousand square yards a night, and now
Mhm.
I got half that,
Yep.
because you're cutting my speed. So
Right.
again, things to have a discussion about
Yep.
in the process. Sorry. Let's flip over. Let's talk about paving
Sure.
a little bit. Some of the things we talk about, from an end game perspective, do we have the thickness?
Mhm.
Do we have the width dimensionally, right?
Yep.
Width, thickness, et cetera. Density has to do more with rollers but we're seeing some stuff with pavers that
Absolutely.
can make some good ranges there. And texture.
Mhm.
I'm a huge one on texture.
Sure.
I just think if we get, and you correct me if I'm wrong, and I hope you do, because I've always said if you get the texture right,
Yeah.
that means pretty much everything in front is set up right.
Right. Yeah.
The mix is right temperature, it's uniform temperature, equipment's set up right,
Yep.
paver's set up right, and we're just paving.
Sure.
So to me, when I talk with inspectors and talk with people in the field, which I do relatively frequently, it's like, man, I'm going to stand off the paver on the non-traffic side so I don't get run over, and I'm going to watch that paver go by, and I'm looking for and I've got video clips that I use in stuff that I do where we're looking at stuff, but then I just want to look at the asphalt.
Yeah. Yep.
Are you?
I completely agree.
Okay.
I mean, yeah, of course you can always look at angle of attack, and maybe we're riding a little on the trailing edge or a little more on the nose. But man, if that texture looks good, especially on the joints, right? We're letting the screed, more importantly, do its job.
Amen, bro.
Man, you're 80 to 90% of the way there, if not more, in my
Okay,
mind. Yeah,
perfect. Now
absolutely.
then we're in sync on that
Yep.
one. So,
Yep.
good deal. So, just like the milk can do different things, let's talk about what the screed can do
Sure.
on the back of the paver, because pretty much all we see here, those are the end gates are pulled in there, but
Yep.
this has got extensions that move in and out.
Sure.
I think you can see it on this one, and I know you can see it on kind of the wide shot there. These hydraulically extendable screeds.
Right.
Back in the old school days, they used to have rigid extensions, and
Yep.
they still do.
Sure.
But this is the ability to move these extensions in and out has helped. Production
Yeah.
out the crazy. We can do all kinds of stuff now. So let's talk about what we can lay.
Sure.
Okay, now we can go. Say a standard width is 10 foot,
Right.
whatever that is in meters.
Right. Not 3
Oh,
meters.
see, okay.
Yeah.
All right. Checking to see.
Had
if
to think, yeah.
Had to think about it. But they can go kind of depending on the equipment.
Yep.
You can go from 10 foot to kind of how wide?
Generally, your standard 10-foot paver with hydraulic extensions out of the box is going to be roughly 10 feet to 20 feet.
10 to
Right.
Okay, so it can double its width.
Right. Maybe 19.6,
some in that-
19.8,
okay.
but everybody pretty
Okay.
much says 20
Okay.
feet. Yeah.
So is that 20 foot straight across? Or can I? What
Yes.
can I do with slope on that?
So couple things is obviously you've got bolt-on extensions. You could go wider than that in a lot of cases. As far as slope goes, yeah, you could put crown in the middle of the screed, right?
Okay.
So if we got to break the screed right in the middle, we can do that.
Okay.
There's also the ability to adjust the extensions, right? So if we need to put almost a quarter crown or parabolic into the pavement, we can do that as well with certain screeds.
Okay.
So you've got a lot of flexibility, but again, it comes down to when you're looking at the paver, when you're looking at the mat coming out of the screed, number one, obviously checking our thickness, but also how does it look, right? Because again, if we see we've got some roughness on one side, or we see we've got a line, we may have an issue where the match height between the extension and the main is not set properly,
Okay.
right? So again, it's looking at those those key indicators, those little things that tip you off, those things that make you go, hey, is that right? Let's ask a question. Let's talk about it.
So how hard is it to change those match height
Ty-
issues?
Typically, it's the push of a button.
Yeah.
If it's an older design, maybe it's adjusting a chain. It's a crank, right?
Yeah.
But generally speaking, it's pretty much just push a button with now newer technology nowadays.
Okay, so generally when we're paving, I'm an inspector on a roadway, and contractor A is, started off the joint, we're get up and running, we're going down, and I've got 2 lines on either side of
Yep.
the paver.
Yep.
Okay, I can is that a fair ask to
Sure.
say, hey, can we make those go wide?
Absolutely, yeah.
Okay,
yeah.
and it should be just a matter of
Push a button or
everything
again
lined
turn
up.
a chain.
Yeah.
It's depending on the make, model, the age, but
Okay.
it's a reasonable request and it's reasonable to make the adjustment.
okay. And so if I'm changing slope now, now I'm paving different thicknesses.
Correct.
Right?
Yep.
So what's that going to look like?
Well, I mean, obviously, it can throw off your total yield, right? Throw off the cost of the job. It can create a lot of other issues from a slope perspective, from a drainage perspective. So yeah,
I
it's
don't get it the right way.
correct. Yeah,
Right.
so it's definitely. I mean, it can create a lot of issues if you don't address it.
But I could do some milling to improve slope.
Correct.
I could do some paving to improve slope.
Correct.
But what if I'm milling, and I've seen this, where generally pavements tend to be rather more flat than sloped,
Yep.
particularly in flatter areas.
Yep.
And if you try to go back and mill that out, you may mill through the asphalt into the base.
Correct.
And now
Yeah.
Yeah.
Now you got bigger issues.
Now we got bigger issues
Yeah.
because I may not be putting back enough material. I've taken more material out than I'd be putting back in the right lane
Yep.
where the heavy traffic is
Right.
running.
Right.
And so that's just something to think about if you're trying to do cross slope correction and you're trying to correct it all on the downhill side rather than on the uphill
Yeah.
side.
Yep.
You'd almost be better off putting
Yeah.
some asphalt on the uphill side to improve the slope
Correct.
than trying to just mill down into the pavement,
Right. Or
assuming condition of pavement. and
right.
everything
Yeah.
else.
Or raise the center line. You see that pretty
Okay.
often, right? Where
Okay.
where you don't have the ability. You need to fix. You need to fix slope. You need to fix cross slope, right? But you don't want to mill down through to your point to where you get into base or you get into subgrade. Raising the center line of the road can always be an option.
Wow, okay.
Especially when you've got to go back up against curb, right? And you want that curb reveal to be what it was
Stay
prior.
where it was.
Correct.
Oh, okay.
Yep.
All right.
Yep.
That makes sense.
You've probably seen, plenty of roadways where they put a curb back in the 80s, and what was a 6-inch curb is now about a 2-inch curb.
'Cause it's all filled up.
Because it's all filled up,
Or
right?
flush. Yeah,
Right.
or
right.
flush. That's no. But I mean, it's because they don't want to have to deal with. I mean, there's obviously a cost to remove
Sure.
material.
Absolutely.
right?
Yeah.
And so, in some cases, well, we just want to put an overlay on it.
Yeah.
Okay, well,
Yep.
you can do that, but
Yep.
eventually, again, like you said, everything's got consequences.
Correct.
And all of a sudden, my road's not draining
Mm-hmm.
because I filled up my gutter, and now I get water underneath the roadway, and the roadway blows up, and it's like,
Right.
oops, now we got
Right.
a problem.
Right.
So and so and so.
Yep.
So, and same thing with ride and et cetera. So, good deal. Let's see, man, you're about out of time.
Maybe we need to do a
We
part
may need
two.
to do a part 2 on this one. You come back?
Sure.
sometime?
Yeah,
All right,
I'll
that's
come
cool.
back.
So let's jump over to the inspector side real quick.
Sure.
Okay. So I'm inspector. I'm watching a milling operation. What should I be looking for if I'm watching a milling operation?
Obviously watching from a safe distance,
Okay.
watching off from the side.
Because there's huge blind spots.
There
with
are,
these things.
and the other thing that is not thought about real often is when you're walking right behind. I see guys, they'll drop a machine into the cut and they'll go start checking depth right behind the mill. You've got all that momentum of that drum, and you've got all that horsepower driving that drum. If that machine strikes an immovable object, let's say a
Like a
piece of
manhole?
steel or a manhole,
Yeah.
that machine can jump back rapidly.
Actually,
Yes,
the whole thing can move.
the whole
really?
thing. 60,
You've seen that?
I have.
Wow.
And it will
Because
scare you to
these
death.
things are 80 to 100,000
For
pounds,
sure,
right?
yeah. I mean, your standard 7-foot mill, 600 horsepower is going to be somewhere in the mid 60,000 pound range. But yeah, I've seen. I'll never forget it. It was outside of Indianapolis, and we were milling along. It was a mill and fill, and found a
somebody's
structure.
right here.
Found it didn't. Luckily, no one was behind it, but found a structure, and that machine jumped back, 6 or 7 feet. just faster than you could move. So
No kidding.
yeah, so from a safety perspective, again, from a distance, don't ever stand right behind the mill. Don't ever go check depth right behind the mill.
Okay.
That's a really common thing. So again, from an inspector standpoint, looking at the pattern, looking at the milling operation, from how the machine is moving, how the pattern looks behind the machine. And again, pattern can be subjective, but if guys are running 100 feet a minute down the road and you've got a lot of grooves, then there's probably some questions or some discussion that we want to have.
Okay.
Water, right? Water's a big thing. If we've got a paving operation right behind the mill as an inspector, we need to obviously make sure we have enough water to cool the teeth and to keep the dust down.
But
we don't want to be flooding it.
We're
if
not
we
making a Slurpee.
Yeah,
Right.
exactly.
Okay.
So again, looking at matte texture, looking at the moisture content, looking at are we dropping a lot of material off the conveyor, for example, or out of the front of the drum that's causing the machine to ride up on material, can cause uneven surfaces. So
okay.
there's a lot of different things to look at, but again, if things are moving along nice and smooth, we've got our depths, our patterns nice
Check
and
your
consistent.
slopes.
Yeah.
Yeah.
And I'll say more than anything, consistency on a milling operation or a paving operation is key, right? We talk about that all the time.
Right,
I'd
Brian.
rather have guys running 30 feet a minute and consistently filling trucks than I would run, 90 feet a minute and then they sit
90
for
to
45
0, 90
minutes.
to 0,
Yes,
90 to 0.
yes,
Okay.
yes.
Yeah, because I assume there's going to be that machine when it gets loaded to unloaded, it's going to change a little bit.
Yeah, it's just like
gonna,
it's just like a boat in a
Oh,
lake,
gonna
right?
plane
Planes
up.
out,
Okay,
right? So
okay.
as that machine goes, it will plane out, right? And then when it stops, everything
Both
kind
of
of
them.
correct.
Yeah.
Everything kind of settles, right?
Okay.
It flexes, right? And we're talking a minimal amount, but still, again, if we're running 100 feet a minute, we stop. We're running 100 feet a minute, we stop. There's a likely chance that we're going to leave a small indention where we stop every single time. So
and
again,
then when we talk about IRI measures everything.
yes.
Okay, inches per mile, and all those little things add up to big
Yeah.
things, and all
Yep.
of a sudden now we've got a problem.
Right.
We're not getting the ride we're looking for.
Right.
Same thing with
Same
with
thing.
both of these machines.
Yep.
Exactly.
Yep.
Exactly. Okay. Inspecting a paving operation.
Yep.
What should I be looking for on the paver?
So again, texture. I think texture is a huge part. Letting the machine do the work, letting the end gates do the work, right? So that we're not raking the joint.
Not
Because
raking the joint.
again, we talk about it all the time.
Yeah.
But when it comes to raking the joints, 9 times out of 10, you're not bumping that joint. You're actually pushing the material away from the joint. And then where's the first point of failure? In the joint.
the joint.
Right?
Yeah.
So letting the machine do the work, seeing consistent operation, watching the augers, right? If the augers are nice and steady and slow and consistent, right? Versus speed up, slow down, speed up, slow down. If they do that, then we change typically the head of material and the way that screed rides, right?
Yep.
Because it's a free floating screed. It
Yep.
floats along on the material. Again, how we're dumping the trucks or how the material transfer vehicles feeding the paver, consistency, right? That's, again, consistency is a big piece. A lot of the really good paving operations, you walk up on and, the screed guys are walking alongside the screed and everybody's kind of talking and doesn't really look like they're doing much, but the paver is just going, right?
And they're laying asphalt.
It's laying asphalt.
Yeah.
We're doing a good job.
Good deal. I 100% concur. We're gonna have to pull here. Maybe we do come back. We'll
All
do a
right.
part 2. We're doing history of asphalt. Different parts now. We got another part 3 coming on that one coming up. And so I've really enjoyed this. I always give you king for the day. King for a day. You get to change anything and why. What would you want to change? It can be
Yeah.
your open discussion.
I don't know that I would want to change anything as
Okay.
much as I would want to say we as industry, we need to do a better job of telling our story. We need to continue to push telling that story. And again, from my experience, my history, right? I didn't go to college. I went through the technical trade school route, right? There's so many options, there's so many directions, and there's so many companies. There's several companies that I've worked for that, hey, I don't care that you don't have a 4-year degree. I'll train you, I'll teach you, right? If you've got some foundation, whether it's military, whether it's technical trades,
And a good attitude.
great
and a
attitude,
willing to work.
That's right. We
Yeah.
can teach the rest.
Yeah.
There's a lot of that attitude that we can't teach, but I think telling our story, getting out there and doing things like this and a lot of other platforms that are out there, I think we need to just continue to do that and push that conversation because
Awesome.
it's it's a best kept secret in a lot of ways. It's a great industry, and the people are fantastic.
Good deal. Good deal. All right. Well, that's all the time we've got today. Again, thank you, Matt, appreciate you spending some time with us today. Just want to remind you guys that these things are posted on YouTube and Apple Podcast, Spotify, and some other places. This airs, remember, on the third Thursday a month at 3 p.m. Central Time. And you can go to texasasphalt.org. You can go to apextex.org. And sign up for it. Would like to invite you to go to Apex Tex. That's the Asphalt Pavement Exchange. And look what we've done. Look what we've done on our website. And man, we've got some cool stuff coming in the next couple months. So just a little teaser on that one. So in the meantime, see you next time on Everyday Asphalt. Be safe and ever forward, everybody.